defining moment for disaster risk governance. Around the world, the frequency, intensity, and complexity of disasters are increasing. Climate variability is compounding existing vulnerabilities. Urbanization is concentrating risk, and cascading hazards are challenging traditional response models. At the same time, we are witnessing unprecedented advances in AI. So, at this point of time, how does India bring or develop a model with AI for resilience? We believe that the next frontier in DRR is not better algorithms alone, it is institutionalizing AI within national resilience architectures. India's experience offers a unique perspective. We operate across Himalayan risk, coastal cyclones, riverine floods, heat waves, and urban flash floods. We manage complexity across federal and state systems, and we have demonstrated DPI at population scale. Our proposition today is not that India is merely an AI innovator, but India is evolving as a resilient systems architect, integrating space, technology, meteorology, digital platforms, governance frameworks, and community centered dissemination. So, today's panel discussion brings together government leaders, multilateral partners, developmental institutions, and technology pioneers to examine a critical question, that is, what institutional, financial, and governance reforms are required to scale AI from pilot projects to national and global resilience systems. Before we start the discussion, let me invite and call on the stage to for the panel discussion His Excellency Dr. Avinash Ram Tohul, the Minister for Information Technology, Communication and Innovation from the Republic of Mauritius. Welcome, sir. He is key contributor to national strategies for AI in resilient infrastructure and South-South cooperation. I would like to invite Ms. Beth Woodham, Senior Manager from UK Met Office. She is a specialist in the disaster risk reduction via forecasting innovations and AI explorations for predictions. Welcome, Beth. I would like to invite Mr. Som Satsangi, former SVP and Managing Director from Hewlett Packard Enterprise, India, with industry insights on AI deployment in geospatial and climate analytics. Welcome, Mr. Som. I would like to now call upon Mr. Nikhilesh Kumar, CEO and co-founder for Vasar Labs. He is an innovator in leveraging AI for DRR. Welcome, Nikhilesh. And lastly, Mr. Pankaj Shukla, Head of Customer Engineering, Google Cloud India, for practical AI applications, hazard mapping, predictive analytics, and EWS scale-up. So we move beyond demonstrations and focus on double integration during this panel discussion. So my question first to Minister for IT, Communication and Innovation, Republic of Mauritius. Minister, the small island developing states face existential climatic threats. From your perspective, what policy reforms are required to institutionalize AI-enabled early warning and alerting systems within national governance frameworks? And how can countries with limited resources ensure sustainability in such ventures?
Thank you, and good morning, everybody. Thank you for the opportunity to be here amongst you. First of all, I would like to say a couple of points before I get into the actual response there. Today, just like we have the physical world, we have a virtual world as well in which we all live. And that virtual world is so much bigger than the physical world we can see here in front of us at the moment. And just like disaster can strike the physical world, and that is the scope of the discussion, disaster can also strike the virtual world. And as we grow in dependency on the virtual world, on our digital systems, we should be well aware that disaster is not just the flood, the cyclone, the drought. Disaster can also be the cybersecurity attacks that can actually create havoc in our lives. Therefore, it is very important that the scope of the discussions when we look at disaster be also extended to the virtual world and cybersecurity attacks. Now, having said this, in terms of policy reform, it is very important that we also create this bridge between the physical world and the virtual world. And I will explain myself. Just imagine, as we speak here, there is a big fire that breaks out in one of the halls. And because it broke out, there are automated connections that go to the fire services, to the medical services. They will proactively now start driving to this place. But when they come to this place, where would they know where are the people? Because their main objective is to save the lives of the people. Secondary, the material. Where would they know where are the people? Do they have a plan, a structural plan of this space? Do they know where do the pipes cross? Now, I'm talking about a digital twin. It is really important that we create that digital twin which will be the bridge between the physical world and the virtual world. And the architectural map of that digital twin should be accessible to a certain set of operators, the medical, the fire services. Now, this is part of the reform that we are looking at. And in a small administration, it becomes easier to do it, as opposed to a huge administration like India. Now, there's one more thing in there. As, let's say, we also have the structural plan, how do we know where the people are? Can we have heartbeat indication? Can we have the thermal map of the place so that we know wherever there's 37, 38, 39 degrees, well, 37, 38 is better. Do we know where the people are located so that when the fire services come, they go straight to that spot? So this is very important. And another reform that is important that we be aware of is that when there is some kind of a pandemic, there is, and which is contagious, there is human-to-human virus transfer. Now, we are all very excited about artificial intelligence, but we are also aware that there is this possibility of virus infecting systems, right? And just like virus infects people, virus also infects systems, and virus get contagious in computers as well. We all know that. Therefore, we need to also have mechanisms to protect, because if we have a message that goes through an early warning system to people, this already creates an alert in the minds of people. The adrenaline surge starts already. But if that message is infected, it can create a lot of disruption in our daily lives. And this we need to be very careful of. Therefore, in terms of reform, the decision-making process, and I think it was somebody earlier mentioned in the previous panel, the decision-making process is automated. Now, automation can be from 10% to 100%. And 100% automation in the field of AI, where it concerns the lives of people, can be dangerous. Therefore, human in the loop or human on the loop is critical in these kinds of environments. And this is also part of what we are looking at in Mauritius. Yes, it's true that as a small island developing state, we call it SIDS, we have our own set of flash floods that can actually occur. Within a couple of hours, we can have flash floods and we can see cars floating around already. And this has happened in the country. And we don't want that to happen again. Therefore, there are early warning systems that we are deploying, like cell broadcast systems, which we have planned to deploy. Now, again, the message that goes into that system should be a message that is human verified. That is, decisions like these that are sensitive, highly sensitive, cannot be 100% automated. That's part of our policy as well. And want to ensure that humans are involved. Because machines cannot decide for humans. Humans decide for machines. And this needs to be critical and needs to be given the attention that it deserves. And I believe Prime Minister Modi ji also mentioned in his intervention yesterday that there is a great necessity to ensure that humans remain part of the decision-making process in the application of AI for disaster management. So these are a few points I wanted to mention. Thank you.
Thank you, sir, for giving insight. Thank you, Mr. Sir, for giving your valuable insights in developing resilient governance frameworks, which actually are scalable across the nations. And this is the way to go. A resilient system, which is resilience to even cyber attacks and also sustainable, meaningful, and not giving any, fatigue of alerts also is very much vital for a robust system to be effective across all disasters. So we now come to the second panelist, Ms. Woodham. Uh, my question to you is, the national meteorological agencies play a crucial role in operational forecasting and early warning delivery. From the perspective of the UK Met Office, how can AI complement physical weather and climatic models to improve forecast lead time and basically impact-based warnings to gain public trust? And what institutional partnerships are necessary to ensure that AI-driven meteorological insights translate into actionable decisions and actions at national and local levels, with special emphasis on low resource countries?
Hello? Yeah. Um, right, thank you for your question, and thank you. It's a real honour to be part of this panel. So, at the Met Office, we are currently developing machine learning weather models, and we absolutely do not see these as a replacement for our physical models. Our our plan over the coming years is to step by step implement these models through blending. This could be hybrid models, physics-based and machine learning-based. It could be blending the output from both of these models after they've run. The truth is we don't know what the answer to this solution is yet, but in order to build the trust amongst the users of our models, the customers of our data, we're certainly not going to have a complete shift. We are going to do this step by step, increasing our blend as we become more confident with the data. So it's from this conference, it's very clear that companies from the private sector are developing these models. In the public sector, of course, we're developing them too, and sovereign capability remains really important. But for public sectors, we really need to have that co-development. At the Met Office, we have a long history of co-developing with partners like India, so through WCSSP India and through WISER Asia Pacific. We have these partnerships. We've co-developed physics-based models, and we really want to do the same with machine learning models. As well, at the Met Office, we're starting standardizing our benchmarking and evaluation. We really want to make sure that when we're doing comparisons between machine learning and physics-based models, we're being fair to the physics-based models. There's a lot of metrics we can look at that show machine learning models are doing well, but are these the metrics that are most important to users? Therefore, not only do we want to co-develop the actual models with partners, we want to co-develop the benchmarking and the tests that we do on these models. Thank you.
Thank you, Beth, for giving your insight into how the national meteorological agencies may plan to use AI into the systems. So now we move towards the technologies, so that how do we really create resilient systems for forecasting. So my first question to would be to Mr. Som Sasangi. Uh, uh, the private sector innovation has advanced rapidly. So the first foremost question I think which comes to my mind is how can technology providers design AI systems that are interoperable and with sovereign data architectures, because that is the crucial issue to be cracked. So we have to design AI systems that are interoperable with sovereign data architectures and compatible with diverse governance ecosystems. For a country like India with federal, the government and the state governments. So this is a very vital nut to be cracked from the technology's point of view. And similarly, what standards of explainability are necessary when AI informs life-saving decisions? So your
Yeah,
insights on that.
thanks, Manish. Really a great question. And probably in this room, I'll be calling something which is very, very important because just when I walked in, I've heard Mr. Martin, and he spoke a couple of points which are so important and critical for a country like India. He spoke about the governments, he spoke about the procurement policies, and and the scale. So all these three things are so important and critical when we look from India's standpoint with 1.2 billion plus citizens. I've been the managing director of Hewlett Packard Enterprise for last 9 years, and I know I've been involved almost in all large critical infrastructure project, whether it's UIDI or any kind of transaction, COVID, all application, and we know that all these things we have developed at the scale and deliver. Probably when we look, the most important aspect of the human life with the climate change, the disaster which is happening across the length and breadth of India, on coastal side, so, but somehow, are we ready today? I don't think we are ready. And I'll give you some pointer which are very important and why it's not happening to the Mr. Martin point. And I'll just, while India has very ambitious plan for national supercomputer mission way back in 2015, where India has said, okay, we'll be investing 4,500 crore to develop some of the supercomputer, which will be the high class. But in last 10 years, what we have developed is some 37 supercomputer with just the 40 petaflop of capacity. Is that sufficient? Now we are planning, okay, we'll add another 50 petaflop. But when you look at the global level, the kind of infrastructure which is required, if we have to manage in a real time this alert and warning system, and I'll give you one or two example in United States, the top computer system which have been developed and deployed to do these things, they have got a capacity of almost 1 to 2 exaflop, and 1 exaflop is close to around 1000 petaflop. Whole India, we don't have even today 100 petaflop of data, and US, there are multiple systems which provide this real-time information, and each of them, one is Al Capitan, which is 1.8 exaflop, then Frontier system, which has been deployed by the Oak Ridge National University, has got 1.3 exaflop capacity. Aurora, which is recently deployed by the Argonne National University, has got 1 exaflop of power and capability. So these are the kind of system which are deployed so that actually they can take the power of AI in a real-time environment, where it's a geospatial data or it's satellite information data or it's any kind of live information, and analyze these things with the help of AI in a real-time environment and provide the alert much ahead of those things. Somehow we are not able to provide. So in India, if we want this early warning system to be done, I think our main focus needs to be how we can have the core infrastructure which will meet the requirement of this. And last couple of days in every discussion, this is what is coming out for the global CIO and CEO, that probably India need the core infrastructure which we have not developed. Now, we might say, okay, we are doing 10,000 to the AI and all, but that is getting distributed to a large number of tech and SMB guys who are developing the application. But what government needs, because it's a sovereign's data, that government needs to buy this kind of infrastructure. But I know each of this system will cost anything between 400, 500 million dollar to $1 billion. Government may not be able to spend that kind of money. So probably that's a place where private partnership becomes very, very important and critical. So my request is that probably department should be looking how the large global institution and technology partner can bring the core infrastructure and technology, because today technology is not a barrier. It's an infrastructure and scale and the procurement process and some of these policies, how the various data will be getting integrated is a problem. So if we can address these things to the scale, probably India has done on the DPI side, where we have implemented, and the best example to the global level where the UIDI is being used almost by almost more than 800, 900 million citizens in the country. We can deliver that. We have got a capability, and with all these AI transformation which is happening, our Honorable Prime Minister already said that India is going to be leapfrogging on those things and going to be the global leader in the AI space. With all those technology embedded along with the capability what India has got, only what is required, the infrastructure, but infrastructure will come with a huge cost. When you are going to get the infrastructure, another element come is the power, energy, and water cooling. That's going to be very critical. So somebody has to look the all the three aspects. You can get the infrastructure if you don't have the power. So we need to have the power which can help and power these kind of systems. So alternative power resources are going to be very, very critical. There will be all water cooled system, because they will have hundreds of thousands of GPU and CPUs running together kind of thing. They will require a huge power and huge water capabilities, so need to have that things. So India need to start thinking on those lines to create that things. If we have to protect and we have to get the right early warning alert to save the life of millions of citizens in the country. That's my request. Thank you.
Thank you so much. I think very aptly summarized by you. There is no doubt that DRR offers an opportunity for India to create a global public good. What our Honorable Prime Minister has set the ambition for India to create DPGs for the global good. And the UIDI is Aadhaar, and based on the India stack, we have seen many things which have come off this table. And definitely DRR also offers an opportunity for us to ponder. So taking forward from Mr. Som, I'll go to Mr. Pankaj Shuklaji. He is the head of customer engineering at Google Cloud and AI. Basically, cloud computing and AI platforms enable real-time analytics at scale. So what are the critical infrastructure investments which are essential to support AI deployment in low connectivity and high risk environments? That's very vital, looking at the looking at the geography of our nation. And how can AI driven dissemination ensure last mile inclusion while mitigating misinformation risk? So your insights on that.
Good afternoon, everyone. So irrespective of the technology, when we talk of disaster management and resilience, essentially what we are trying to do is we are trying to turn the chaotic reality on the ground into actionable intelligence, right? So, for example, the data fragmentation which is sitting with multiple ministries and social media, various places all across, all of that, first of all, needs to be brought to a place, or at least you should have an ability to bring all of that data and turn into a living intelligence. So once the data is there, which is structured as well as unstructured data, then we have the ability of our AI models today, which are multimodal, to make sense of the completely chaotic data, noisy data, into a real intelligence at unimaginable speed. That is essentially what AI is all about. So when it comes to the real implementation of this entire architecture, and the panelists spoke about multiple aspects that how can we use AI, how do we actually implement it on ground? If you look at what we need, and essentially if we talk of AI, broadly it is there at the 5 layers. One is the infrastructure layer, second is the operating system layer which runs on top of infrastructure. And I'm not talking about just servers and data centers, but an operating system layer which scales from a central to an edge location to a multiple regional locations. Then on top of that, the services which are required, platform services which are required to basically build the AI applications, make the use of the right models, etc. Then you have got the models, the multi-model ability of the models like Gemini and various other hyperscalers which provide. And for example, the India AI mission, a lot of Indian providers are building models. Ma'am spoke about a lot of the models which, for example, other companies are building. So the question is that how are we able to make the use of all diverse set of models in a dynamic manner and use agentic AI on top of that to build applications and turn that into a real action which can be disseminated at the places where we want, for both proactive during the response and as well as after the response. So the question is, how do we implement it? So implementation of this will require a framework or an architecture which essentially has a central living intelligence of all the data, on which you are basically experimenting and pre-training the models and tuning using different type of models and building applications. But the real application of that is going to happen at a place which might get completely disconnected from your central place. So you should be able to actually build all of these applications, AI applications, make use of that data, make a single truth centrally, but ability to send that intelligence back to a tactical location. Today it is exactly possible. So organizations, for example, Google and many other organizations are actually trying to build, basically bring all the goodness of hyperscaler cloud for the entire infrastructure and managed services layer as well as AI tooling to on-prem. And then ability to also run those in a completely disconnected air-gapped environment in a zero trust manner. So you have the security of your data and your applications, and then also you should have an ability to connect the edge locations in a federated manner to the central place. But if required during a disaster, you should be able to carry it, a rugged device which basically has a basic small set of central intelligence sitting into that with all these necessary models to basically take action on the ground. And that action could be related to either finding out where are your assets, where is the maximum impact which has happened, how do you actually kind of send the information to various places. So all of those things are absolutely possible today. And while there is huge amount of infrastructure, as Som said, is required actually to train models, build models. But that's happening across the country. We should have an ability to bring all the good models, the models for the right thing, to basically run it on-prem at a smaller set of infrastructure and make a smaller set of that which can run in a tactical location which sits possibly in a very limited infrastructure and compute. That is what we are essentially trying to do.
Thank you, Pankaj. I think for giving Google's insight into building rugged systems at scale deployment of AI solutions in low cost and high risk environments. We have another contributor to the DRR, particularly AI deployment in DRR, could be from the startups. And we have Mr. Nikhilesh Kumar, CEO and founder from Vasar Labs. Now, basically, Nikhilesh, you can enlighten us about how startups can contribute in developing a DPG at population scale for DRR, particularly for countries like India.
So first of all, thanks a lot for giving this opportunity to be part of this panel. It's an honor. Before I go to the contribution to the DPG, sir, I would like to pick it from where the started discussion. Minister sir talked about digital twin. I would like to zoom into a bit in terms of how do we deal, especially with some real use cases on the hazard part on digital twins. So you see today digital twins are really required when we are acting in action to the various hazards across the time in the year. every month has a different hazard. And this digital twin typically you can see in 4 layers. Data layer, which is predominantly the most important to begin the journey. The modeling layer, which is transforming the data into various insights, hazards. The asset and the people layer, which is getting impacted, where we need to know today in personalized and in precision, where exactly we talked about, like if flood is coming, which road, which houses, if a landslide is coming, which area. And the fourth, which is most important, is the workflows to translate the actions. And this is where we see a role of DPI and DPG, because all these 4 layers are not done by one person. They are look into data scattered across various agencies, and we need to have DPIs and DPGs which are built across these data, right from different institutions which are bringing meteorological data, some institutions which are bringing water and other asset-related data, some institutions which are creating different layers like Survey of India in case of India on earthquake, and various other layers. Now, we also see a role of AI today playing a role, and I'll just give an example for that. So we see as today extreme events are happening, one of the first pressure is in the water sector, where we see extreme floods, sudden gush of water coming into the large dams. And dams is one of the most extreme and vulnerable asset that we are all impacted to it. And we would also see that the large dams are perhaps, we have got a good handle to control them during the disaster, but we have small, big number of dams in the country where they are unregulated and they are scattered across in large numbers, and there's no forecast available for them. So how do we churn in real time, in near real time, both hourly and in days time, for close to 1 million water bodies, which anytime can be vulnerable? So one of the solution that we recently saw was translating and leveraging actually the data gap, utilizing AI, and AI sitting on real-time satellite data, 30 minutes interval, radar data coming from, currently all these assets are available from IMD, and translating that into a nowcast. Now that nowcast layer translated into hydraulics to each of the dams. And in Cyclone Montha, close to 5,000 dams were given in real time. So such use cases you see is where data is getting connected, is available in real time in an interoperable format, and then there are players who can translate this data into actions. I see, sir, that contributions where such platforms are brought at national and state scale, and these use cases are also packaged and made available for different recipient departments to translate them into actions. So I would say that, sir. And one more thing I would just like to add, taking this as a forum, sir. Risk assessment and risk reduction both has a very big gap when it comes to data, especially various events across, take about earthquake, take about other type of disasters where parametric measurements historic have not been available, and knowing frequency of location specific frequency of these hazards has been actually lacking because you don't have a database. Now AI can play a very good role here, where the information is lying in lots of news which has happened and which contains unstructured information on location, unstructured information on the hazard that has impacted, the damages, the intent. So AI can actually uncover these informations and create a structured data sets, each hazard wise, and these will also feed into various DPGs that will further unlock to the insurance sector, to many sectors which will basically benefit from knowing location-specific intensity and also frequency of the risk, sir. I'll just close with that, sir.
Thank you, Nikhilesh. You have aptly summarized that startups in this sector definitely can play a very vital role, particularly for developing a rugged AI systems for India at population scale. Now we have heard the panelist from the Indian perspective, since we are running large systems. So we would like to also to have all the members to have the benefit of the insights of how the national systems are functioning in India, and how technology is basically being deployed at scale to for DRR perspectives. So firstly, I would like to get the insight from Dr. Mrityunjay Mahapatra, the DG of IMD. He's here, and IMD can elaborate on how robust AI-based systems can be deployed, are being deployed at population scale in the Indian context. Dr. Bapat.
Namaskar, good morning to all of you. Respected Dr. Kamal Kishore Saab, Atasnan Saab, our Krishnamurthy Saab, and distinguished panelists, and dear delegates, friends and colleagues. At the outset, I congratulate NDM for organizing this session, which has given a lot of thoughts to each of us who are represented here. I'll just start with what the initiative has been taken up by the UN and the WMO. A clarion call was given in 2022 that the early warning for all. And when you go for early warning for all, it includes all the countries, all the people, and all sectors, all strata of the society. So with that, when it came up that, actually less than 50% of countries had the early warning at that time. Now number is increasing, but still the time is short now. By 2027, we have to achieve the 100% towards the early warning for all. It is a long goal, and if we review now, we find that during these last 5 years, there has been a huge jump in technology, and AI is one such technology which is helping for extension of the early warning for all. Looking at the various components of that, you need first the risk knowledge at each and every point, what our friend told just like Nikhil. And it is not possible with the existing network of any country to have the risk knowledge at each and every location. But at the same time, there are unstructured data, as it is told, which can be utilized to create the knowledge, to create the risk, hazard, vulnerability assessment, which can be the historical knowledge, which can be utilized in real time when you go for the prediction of any severe weather event. Next point comes the early warning. Yes, over the early warning aspects, you will see that there has been also a huge jump in recent years with the inclusion of many AI-based models. You will find that each and every large NMHS, you can say, established NMHS, they are utilizing AI. IMD is also utilizing AI for taking a decision with respect to the early warning. At the same time, I will tell you, AI has come off as a hybrid model along with the physical models. We cannot get away with the physical models, because physical models provide you the physical understanding, the reasoning, and hence the human knowledge gets into the picture with the help of these physical models. So therefore, AI has to be suitably connected with the physical models. That's what everyone is doing, starting with European Center or in Indian Center. And to do that also, there's been many collaborations and integrations towards that. So after that, if you look at the basic backbone, which is the modeling starts with the basic assumption that weather forecasting is an initial value problem. You cannot give weather forecast if you do not have what is the initial status of Earth, ocean, and atmosphere. So therefore, the basic thing which we are talking of now, that is already defined in the physical modeling system. Unless you improve the data, initial data, with all types of observational tools and techniques, you cannot improve the weather forecast. So therefore, here, by collecting or by creating the data with the help of AI also will go a long way in improving not only the AI models, but also the physical models and the hybrid models. Once you have to get data, the quality of the data can be improved with the help of the AI. There are, I'll tell you, from satellite we get data, a lot of data, but only 5% data from satellite is usable. We cannot use the data from satellites because of the quality. And further is that the quantity. You cannot accommodate all types of data in the physical modeling system, as our friend Satsang Saab was telling, that you need infrastructure. You do not have a computational infrastructure where you can utilize 100% of satellite data. So, yes, you are true that in India we do not have sufficient computing infrastructure. We have at least now 28 petaflop in IMD, and outside, of course, with National Supercomputing Motion, we have come up like that. But that is not sufficient. And therefore, there is scope for public-private engagement for the augmenting the computational infrastructure or the digital infrastructures. But at the same time, there is another scope because of AI. Now, box model has come up. A poor country, a poor small island nation cannot venture or cannot even dream to have a high performance computing system. They can go for AI system. A box model has come up where you can give it to small island nation, and there, with the help of a few GPU nodes, they can have the forecast. And that has come up, and it will grow gradually. And we will have the affordability to early warning with the help of this GPU-based AI-driven or data-driven models. So after that comes the forecast. Once you come to forecast, now we have already come up to AI consensus. But physical consensus plus AI consensus, then again you will go for the final forecast. That is way. Then finally you go to the sectoral applications. There is a huge scope here with the improvement of economic conditions and societal conditions in every country to improve our decision making for each and every sector, and there AML can play a role. So I urge upon all the industries, academia, R&D, and think tanks to collaborate with NMHS, especially with India Meteorology Department, other organizations here, to have very authentic, specific, and judicious utilization of AI with limited, reasonable resources available in the country. So thank you very much.
Thank you, Dr. Mahapatra, for your valuable insights. Now, since NDMA is the apex national body, which basically will integrate all the varied systems into creating a rugged AI systems, I would like the entire audience to get the benefit of the vision of NDMA from member and HOD Dr. Krishna Vassa. Sir, can you please elaborate how NDMA intends to take this forward to create a sustainable, low-cost, at-scale model for the country?
So thank you very much for giving me this platform. I would like to mention that we already have a huge amount of data that exists in relation to almost all the hazards. Look at the earthquakes, we record all the micro earthquakes, for the entire country, and the kind of data that exists for the earthquakes which are below 3 also can give us a very good indication of the kind of earthquakes that we can experience in the Himalayan and other regions. And this data, the availability of data is going to increase exponentially as we are investing in the observational networks. Almost every mitigation program that we are doing, we have included a significant aspect of early warning systems. In next 5 years or so, every village in India will have an automated weather station. We will have large number of instrumentation for measuring landslides. We are going to at least quadrupling the seismometers, strong motion accelerographs. So we will be investing a huge amount of money in improving our observational networks across the hazards, which will mean that we will have access to still a larger amount of data. What is important is that we need to have that capacity to process the data and apply the AI models and improve the precision of early warning. That's somewhere, that is an area, that is the sphere where we are struggling right now. It's one thing to set up the observational network. The another thing is to how to collect the data, process the data, and generate the information that could be used more so when it comes to informing the common citizens. Scientists is one thing, we are getting huge amount of data, but we are not doing it for the scientists. We are doing it for the people who get affected by disasters. So how do we go about it? And the roadmap is not sufficiently clear. And I keep talking to all kinds of people. Somebody would come and say that you set up a huge data center. No, okay, that's fine, great. But people also say if you are setting up a huge data center and you are not really empowering all the early warning agencies, then how are you going to justify the investment in data centers? The data comes to individual agencies. How do the data center and the individual early warning agencies interact so that we have a good model available? So, and we don't have unlimited resources. So the point is, this is where we need more clarity. How do we go about using our existing networks to improve the precision in early warning, risk information, through a gradual incremental way of building capacities that of course includes the data center, that should include improving our connection with the LLM models. But it's also very, very important that we need to find a way of improving the overall architecture. That is one area where we are struggling and where we need some guidance. Thank you very much.
Thank you, sir. I think we are coming to the close of the discussion. I'll request Krishna Avasa sir to please give a mementos to our panelists. Sir, please. Since we are working on a tight schedule.
Yusra, give the bag. And may I also then request all our dignitaries in the front row to, after this memento is over, for a quick photograph and then we vacate the room. Thank you. I'll request the leadership from the states of Tamil Nadu and Andhra Pradesh, Telangana also to come, please, in the front for the photograph. We are very happy to inform that most of the states are also represented from the State Disaster Management Authority. Advisor PP as well, please join the
Come and visit me.